Just getting set up, y'all. Let's edit the title of this. We're calling Solana. Chainlink testing. Rust, JavaScript, Solidity. Done. Are my tags like IRL English? Can we get programming in here? Programming, software, development, anything else? Programming. I guess it's not web development. Computer. No. Engineering. Programming, software development. It's like blockchain a tag. No. Chainlink should be a tag. Bitcoin, crypto, software development, programming, English, engineering, IRL, creative. Sure. Done. Pop out the chat so I can chat with y'all. Let's do some Solana stuff, huh? All right. GitHub, C dot, Chainlink, Solana. So today, what we're looking to do and I always forget where the frickin' thing is. One more second. Oops. We're looking to try out this Chainlink Solana Flux aggregator. I posted, here it is. I posted this issue last time. And I got, maybe you should try again. Sometimes this happens. So let's try again. Whoa. Let's even code. Oh, this is the Python Chainlink. Oh, whoops. Close that. Sorry. Yeah, so I updated this issue last time we streamed this. Let's see if we can. Language server for Rust. Sure. Okay. Whoa. Pull request. Review feedback. Interesting. Okay. Price feeds. So don't link. So this is the Solana Chainlink aggregator. This is their UI. They have Bitcoin USD running, and they have some test nodes doing it. So, okay, yarn install. Oh, wait, no, I got to repull. Git pull. Cool. Yarn. I kind of want to, like, reinstall, but actually, it looks like it should be fine. Set up a wallet for the Flux aggregator admin. We already have one, which we tried last time. Unless it's like broken now. Or just really freaking slow. Yeah, with our Tensol here, Flux admin 2. So I don't think I need to generate a wallet unless this does something that, let's just follow the instructions, huh? Whoa. All right, here here's our stuff. Let's even just, let's add it to our little notes here. Oh, looks like this is what we did last time. Let's airdrop it, which is pretty cool that works. And we should be able to see that on like this thing's testnet. I forget what why is my computer so slow right now? I don't really have that much going on. View on Explorer. We should be able to do the address here. It should have 10 sol or 0. Oh no, excuse me, this is mainnet beta. DevNet. 10 sol, perfect, okay. Whoa, let the light drive down. Do this. I think we have a .env. Add it to this mnemonic. Great. Aggregator setup. Build and deploy the Flux aggregator. Okay, here's where it busted up last time. Build and deploy. Ooh. Ooh. Compiling Flux aggregator here. So this is the Flux aggregator. All this Rust stuff in here. Excuse me. You're on Chainlink deploy program. So now we're actually going to deploy it, right? Build, deploy. Okay. I like where this is going. Where this is going. We're already doing better than last time. Is it this camera or this camera? It's this camera. Okay, cool. How's everybody doing today? Oh, that's a nothing. Let's not use that one, huh? Yeah, how's everybody doing today? Otherwise, the few of you guys are watching. It's still deploying, so we're gonna let it take its time to deploy. Yeah, the benefits of the blockchain world. You just get to wait around. Benefits of blockchain engineering. You just get to wait around. Wait for stuff to deploy. You guys are either all early risers or it's the other side of the world and it's like a normal day where you are. Whoa. Or maybe it does take this so long to deploy. Oh, program ID here. I'm just gonna copy it. Deployed aggregator program. Oh, that's actually sick. It's gonna work. So apparently we just deployed the Flux monitor in Rust, which is like pretty cool. Create the BTC USD feed that accepts max and min U64 as valid submission values. Yeah, excuse me. Add aggregator. BTC USD. Submit interval 6. Min submission value 0. Max submission value. This thing. Submission decimals 2. I don't know what any of these flags are for. But let's try it, huh? Yeah, I haven't like dove into the Rust code at all, so I'm not really sure what this is doing. Oh, this is like pretty sick though. Feeds initialized, pub key this. Oh my god. Adding an oracle. Next we create, so this added like the program So Solana is like a little bit different, like because the code and the data, or the logic and the data are separated. So this is probably that visualized. Next, we create a separate wallet to control oracles. Okay. This is wallet 2 to control our oracles. Wallet 2. This controls oracles. And then we'll airdrop at 10. That's pretty cool that we have this airdrop address. And then we should, I'm assuming this works because it already worked before. Add this wallet to ENV Oracle mnemonic. Okay, so this is one oracle that we're adding. .env Oracle mnemonic right here. Oracle mnemonic. Next, we create a new oracle to the feed we've created previously and set its owner to be the new oracle wallet that we've generated. Next, we create a new oracle to the feed. Okay, we have this add oracle command. Feed address, oracle owner. And set its owner to be the new oracle wallet that we generate. Okay. So this is going to be the feed address. Is the feed address this? Feed address 2J. Yeah, it's that pub key. Okay. So for us, it's this. The oracle owner is this new address. So this should add, but this is all just contracts, right? So this is just adding that oracle contract. Okay. Oh shit. Oh, this is upsetting. Air processing tracks an invalid amount of data for instructions. Invalid account data. Failed to send transaction. Index 0, feed address that. Oracle owner. Did I do it right? What is this? FOS. This is the adding an oracle. So yeah, oracle. And this should be the same as this, yep. Wait, so this feed address is the pub key. So, oh, I think I did it wrong. Yep, okay, got it. I did do it wrong. Whoopsies. Aha! Much better. Fuck. Invalid data. Pub key is this. So it's the feed address is the pub key, right? Yeah, feed address is the pub key. And the Oracle mnemonic is the second one. Oracle owner. Forward renew junk valley. Yeah. Failed to send transaction. Transaction simulation. Error processing instruction 1. Invalid account data for instruction or connection. This is all JavaScript that's bugging out. Connection. Oh, interesting. So it does keep track of the stuff we deployed. BT. So this is the program's pub key, and this is the BTC USD pub key. Oh wait, so I probably do need to do this one. Right, Oracle owner, right. Did I fuck something up, guys? Should I just use my like addresses in here? I should just use my addresses in here so I can like see shit better. Export mnemonic words. Shit, I forgot what my password is. Is it this? Cool. Okay, yeah, let's just use these as my mnemonics actually. So let's go to notes. We're gonna start over. Flux admin 1. Great. And then what's the address? Here, flux admin 2. This address. Flux admin 1. Swap. Flux admin. Address. Export mnemonic. I don't even know if that was the same password. What the hell? Okay, we're gonna go with this for now. Clear all this stuff. This way I can actually see what the hell I'm doing. So wallet deploy.json. So in our env, we're gonna change this. Okay, admin mnemonic. It's that first one that we just made. Build and deploy the Flux aggregator. Yeah, let's just build and deploy it again. So yarn build program. I wonder if this will fuck up that deploy.json file, or if it'll just like overwrite it. Okay. Flux program ID. Is this the address? I feel like I just want to say this is the address, because like balance. This has a balance history. And it has a history. So this can't be it, right? Unless, and I'm not deploying this, I'm just connecting to this. Like I'm just connecting to this wallet. What happens if I deploy it again? Will it give me the same? It gives me the same ID. So this deploy, I don't think this is deploying anything. I think it's just, I don't even know where to like start in Rust shit. Instructions. Well, that's cool. Actually, it looks fairly simple. Yeah, I think this is like a Flux aggregator thing that it's already deployed and it's just connecting to. I don't think it's actually deploying anything. So maybe there's like permissions and I can't actually, I don't know. Let's try a different U64 as valid submissions. Okay. Let's try a different thing. Feed name, we'll call it ethusd. Submit interval. See, where can I find? All right, let's find this add aggregator thing. Or yeah, add aggregator. Command add aggregator. Description: create an aggregator. This is in TypeScript. Description: feed name string feed name pair. Submit interval. Min wait time between submissions. Is this in minutes and seconds? Come on. Submission decimals. So if my, is that 6 minutes? I'm assuming it's 6 minutes, right? Min submission value is 0. Why is the max so weird? Okay, so this is all just JavaScript. So it's just deploying this. Deployer.ensure. Deployer wallet aggregator program. Where's deployer? Is deployer like the same as like Solidity deployers? App context for admin. Open deployer. Utils. SRC utils, okay. Process.env deploy, if not deploy file. Deployer.open deploy file. So this is in the Solray. So this is some Solana stuff. So it looks like Solana uses like similar deployer syntax to Solidity. Okay. We're learning piece by piece. So I don't really know how. Anyways, so this calls that command. It's called ethusd. Sure. Okay, ethusd. This is its pub key. Now, is this the address as well? Owner is this. Owner is yeah. When did this happen? This happened like a minute ago. What the hell? Oh. Still have 10 soul. Is this, I mean, this pub key is clearly not an address, right? This isn't. Okay, well, whatever. That's the pub key. We're not going to do that. We're not going to create a new wallet. Punch now, skate. The Oracle admin. Ah, my jaw is like freaking out right now, you know? I want to like chew some gum or something. I'll be right back. I'm grabbing gum. How annoying is the gum chewing? Let me know. Yeah, it's still freaking out. I wonder if it's a permission thing. Valid account data for instruction. Huh. Yeah, there's not a whole lot of support here, right? Because let's do like failed to send new transaction. Try catch. fn.call. Actually, how do you debug in Rust? Or actually, no, this is JavaScript. Wow. Is there an IPDB in JavaScript? Not really. Okay. fn.call. The definition found for call. The fuck is fn? De-optimization returns at completion. This interface it could have been, and previously designed to take a closure to be invoked without arguments. Well, that sucks, huh? Maybe no. Yeah, this isn't even Rust. This is all just JavaScript. Interfin self. Fails on this try catch thing. fn.call. So what's fn? Shit. I just lost my spot. Interfin. The fuck is interfin? Interfn? Inner function? Well, it's working. Well, last issue is fixed. Unable to add Oracle. Following the README verbatim, I run into the following. On adding an Oracle, I get submit new issue. Okay, cool. Just letting the team know. And let's look at, they also sent us, since we're on here anyways, let's see if we can do anything else. He sent me a Python one. A Python Solana thing, which I want to try out. Programming on Solana, an introduction. Paul X. This is brand spanking new. Intro motivation. This guide is meant to serve as intro to coding on Solana and using an escrow program as an example. I've also created a UI you will be able to use to try your program. Additionally, you'll get to play with Split Token UI. Most of the info in this blog can be found somewhere in the docs or example programs. Having said this, I have not found... Hey, good morning. What's up, Xenobytes? I've now found a guide that both walks through most of the coding theory step by step and applies in practice. I hope this post achieves this, interweaving the theory and practice of Solana programs. It requires no previous knowledge of Solana. While this is not a tutorial, I will link the Rust docs whenever I introduce a new concept. I will also link to the relevant Solana docs. I'm just like punching my jaw. It like feels so weird. I don't know what to do. Maybe we need to punch it on the other side. No, I don't like that either. We're learning Solana today. It's like crazy, guys. Like, I don't know how to describe it. It just like hurts. I hear that popping. I don't know how good that is. When in doubt, punch it. Punch it to make yourself feel better. Anyways, let's go. To achieve this, blah, blah, blah. On Solana, smart contracts are called programs. That is interesting. Let's do this. Make the IR Solana guide. There. Code. Okay. I do not claim to explain all topics because the hello world didn't work, but I hope this will be a solid starting point from which the reader can explore Solana further. If you're new to Solana and Rust and want to finish this post without breaks and leave with a solid understanding of all concepts discussed with links mentioned, I recommend allocating an entire day to the post. I'm going to do a couple hours. If something is not working, you can find the final code here. Or Twitter. I'm going to give you a follow. Funny. Final product. Before we start coding, let's look at the product. I know what an escrow is, but we'll go through it anyways, just in case anybody who's unfamiliar. An escrow smart contract is a good example to look at and build because it highlights well what a blockchain makes possible while still being easy to understand, allowing us to focus on the code itself. Here's a brief explainer. I kind of was hoping that the image would just be the explainer. Imagine Alice has sent an asset A and Bob has an asset Imagine Alice has an asset A and Bob has an asset B. They would like to trade their assets, but neither wants to send their asset first. After all, what if the other party does not hold up their end of the trade and runs away with both assets? A deadlock will be reached while no party wants to send their asset first. A traditional way to solve this problem is to introduce a third party, party C, with both A and B trust. A or B can now go first and send their asset to C. C then waits for the other party to send their asset and then So they don't trust each other, but they trust this other person, so they send stuff to the other person, and then the other person makes the swap or entity. The blockchain way is to reduce that person. Yeah, okay, we're going to skip. Building the Astro program. Alice is transition. Set up the project. Head over to the template repo and click Use Template. Well, I guess we're going to do this. So, let's see, have any Solana learning. Actually, I don't want to do it on the Chainlink dev role. I'm going to do it on my own. Oh, hello? Use template, Solana learning, create repository from template. Clone this. Oh, okay. There we go. There we go. Great. Solana ecosystem is still young, so this is what we've got for now. Let's just take a quick look at this. Oh, this looks manageable. Okay, yeah, I'm with this. We have a couple of Rust things. I forget how Rust's programs start. So I know crates are their package manager. This is like using them, and this is the function. Program ID, I think and is the pointer. Or the pointer deallocator. Oh, I forget. Accounts, instruction data, and then we're going to return, I believe, this program result. We'll have to mess with it a little bit. Go here to I think I already did this. Yeah. Yep. If you don't know how to test Solana programs yet, remove all the test coding. Testing programs is a topic for another blog post. Remove the testing code in lib.rs as well as the test folder next to src. Okay. So now I have no source. Wait, what the? Oh, now I have no Rust. Oh, that's what they want. They want me to start up blank. Got it. Lastly, remove the testing dependencies from cargo.toml. Should now look like this. Sure. Okay. Great. Have a look into lib.rs. I thought I just deleted that shit. First required crates are brought into the scope using use. Oh, my fucking jaw, guys. Sorry, I keep complaining about this. It's just like weird, you know? Like. I just gotta get distracted by the code, right? Required crates are brought into the scope using use. Yep, crates of the package manager. Use is just I'm using it. Yep. Then we use entry point macro to declare process instruction function. To declare the process instruction function, yeah, I forget what macros are actually. We use macros like printline throughout this book, but we haven't fully explored what a macro is and how it works. The term macro refers to a family of features in Rust. Declarative macros with macro rules. 3 types of procedural macros. Difference between macros and functions. I remember being confused by this. Macros are a way of running code that writes other code, which is known as metaprogramming. In Appendix C, we discussed the derive attribute, which generates and implements of various traits for you. We've also used printline and vec macros throughout this book. All of these macros expand to produce more code than the code you've written manually. Metaprogramming is useful for reducing the amount of code you have to write and maintain, which is also one of the roles of functions. However, macros have some additional powers that functions don't. A function signature must declare the number and type of parameters the function has. Macros, on the other hand, can take a variable number of parameters. We can call printline hello with 1 argument or printline hello name with 2 arguments. Oh. The downside, thank you. Okay, the simpler macro instead of functions that macro defines are more complex than function definitions because you're writing Rust code that writes Rust code. Due to this indirection, the macro definitions are generally more difficult to read, understand, and maintain than function definitions. Okay, so for code readability, write functions more often, but because macros do more shit, write them if you want to. My jaw. Okay. Then we use the entry point macro to declare a process instruction function to the entry point program. Entry points are the only way to call a program. All calls go through the function declared as an entry point. When called, the program is passed to its BPF loader, which processes the call. Different BPF loaders may require different endpoints. How long is this? Oh, this is a long... Oh, hey, put memes in here. The reason for the existence of multiple BPF loaders is that it itself is a program. It updates the... If updates are made to the program, a new program version has to be deployed. We can see the BPF loader we are using requires the entry point function to take 3 arguments. Program ID is simply the program ID of the currently executing program. Why you'd want access to it inside the program will become apparent later. Instruction data is self-passed to the program by the caller. It could be anything. Finally, to understand what accounts are, we have to dive deeper into the Solana programming model. The reason we need accounts is because Solana programs are stateless. If you want to store state, use accounts. Programs themselves are stored in accounts which are marked as executable. This was the thing that I was trying to wrap my head around. So there's no state data. Solana programs, which are smart contracts. Smart contracts are programs. Solana programs are stateless. If you want to store state, use accounts. So all the data is stored in accounts. It does so using accounts. Accounts are similar to files in an operating system such as Linux. Like a file, an account may hold arbitrary data. Okay. Programs themselves are stored in accounts which are marked as executable. Each account can hold data and sol. Each account also has an owner, and only the owner may debit the account and adjust its data. Crediting may be done by anyone. Here's an example of an account. As you see in the example account, it has its owner field set to the system program. As a matter of fact, accounts can only be owned by programs. Accounts can only be owned by programs. What about my account? Is that owned by a program? Oh, brilliant. Thanks, Paul, for anticipating that question. Does that mean my own Sol account is actually not owned by myself? And you'd be right. But fear not, your funds are seifu. I hope this is, oh my God, it is to Urban Dictionary. I love the writing style here. The way it works is that even basic Sol transactions are handled by a program on Solana, the system program. Okay, even programs are owned by programs. Remember, they are stored in an account, and these executable accounts are owned by the BPF loader. The only programs not owned by the BPF loader are, of course, the BPF loader itself and the system program. They are owned by the native loader and have special privileges such as blah, blah, blah. Okay. Wait, it's all programs? Always has been. If you look at the system program, you'll see that although the program owns all basic SOL accounts, they can only transfer SOL accounts when the transaction has been signed by the private key of the SOL account being debited. In theory, programs have full autonomy over the accounts they own. It's up to the program's creator to limit this autonomy and up to the user of the program to verify. Okay, so let's... are called programs in Solana. Programs are stateless. If you want to change state, you have to use accounts. Everything is owned by a program. Your SOL account is owned by the, what is it? Hold on. I'm gonna stand. Maybe it's because I slept on my jaw. I don't know. All accounts to be read or written must be passed to an entry point function, okay? Create a new entry point.rs file. Move the lib.rs code there. Finally, register this entry point inside lib.rs. You will have to do this for all files we create. Move, not copy. Entry point process instruction. Function, process instruction. Program ID and pub key. Assuming this is a list of pointers, account info, U8. I forget what U8 is in Rust. Oh, it's been a while since I learned Rust. What? Unsigned integers, yep, okay. Each program is processed by the BPF loader and entry point accounts, blah, blah, blah. Oh my god, it hurts. What the fuck? I'm so sorry, guys. It's like, I don't know why it hurts so bad. We got all this shit together. Okay. Do like how it's separated. I'm just not going to talk for a bit. Sorry. It's like my double check to make sure I'm awake. Token program, okay, so that's like the token smart contract. In the token program, to hold the token, you need a token account. In the token program, to hold an account, you need a token account. In the token program, to hold a token, you need a token account. Both Alice and Bob need an account for each token, so we'll get 4 more accounts. Aha. Since escrow creation and the trade won't happen inside a single transaction, it's probably a good idea to have another account to save some escrow data. Note that this account is created for each exchange. For now, here's how the world looks. Alice main account, Bob main account, token program, Alice token act. Okay. Oh wait, was I supposed to do something? The native way one might connect Alice's main account to her token accounts is by not connecting them at all. Okay, whenever she wanted to transfer tokens, she'd use the private key of the token. Clearly, this would be not sustainable if Alice owned many tokens, right? It would be much easier for Alice if she just had one private key for all her token accounts, and that's exactly how the token program does it. It assigns each token account an owner. Not that... Okay, so accounts are wait, so like... Okay. that is an important difference. Note that this token account owner attribute is not the same as the owner account. Account owner is an internal Solana attribute that will always be a program. This new token owner attribute is something that the token program declares in user space. Okay. We can see all this when looking at a token account inside the Explorer. Let's do that. Token account, address, mint, owner. Right, so this is the owner of the program. Yeah, sorry for being quiet, guys. Just like, it's like, you know? Okay, here's the new thing. References, yep, okay. Program-derived assets. Program-derived address. I feel like I'm getting it, but I don't know if I want to. Oh, is there a UI here? I think I get some of the stuff in here. I feel like I don't really want to finish going through it, to be honest. Okay, but there are some really interesting changes here. But I kind of really want to work on K-base. Sorry, Solana. Actually, I think what we're going to do is we're going to see how many people build stuff on the Solana hackathon. And if a lot of people start using Chainlink there, I'm probably going to want to learn it. But I think at this point, like I need to brush up on my Rust, which I have to do anyways because I know Polkadot does Rust. I know a bunch of other languages here or cryptocurrencies are trying to use Rust, so I'm going to have to do it sooner or later. I think at the moment I'm just not super strong enough. So we're going to do this later. I have an hour and a half left now. Let's work on K-base. This doesn't make sense. We're not going to do this. Store token URIs that point to something like IPFS. I think that's what we have to do. I'm going to draw some inspiration from source cred. They did something cool here. They had two. They had like reputation and they have cred and grain. What was the contribution of all the people? Cred is non-transferable. Grain and distributed to contributors who have cred in that project. Your grain is tied to your cred. So they do it like I don't want to do it exactly like that, but similar. So how does it work? So I post a question. Did they get the token for just posting a question? Maybe we shouldn't figure out like how exactly it works. Maybe we'll just like get an MVP up just to get an MVP up. That's probably more important than like figuring exactly everything out here. Yeah, you know what? Let's just do an MVP. Let's define the MVP here. MVP. User posts question. They get K-base token. Yeah, they get some K-base token. Like we'll keep it super simple for now. User answers question. They get K-base token. Or no, answers question. They get nothing. User answer gets accepted. They get the token. User question gets rejected. User answer questions. User answers questions. They get nothing. Do I want to add this staking bit in here? I think so. I think we have to. User answers question. They stake. Answer. They get the token. User answer gets rejected. They lose stake. Okay, I think this will be V1. Data is stored on IPFS. Chainlink nodes. Data is stored on IPFS. Do I need the Chainlink nodes? What information do they need to give to the chain? Data is stored in IPFS. Because the front end and the back end are totally different, right? Because in the smart contract, you just say, hey, here's the hash. Here's the IPFS, like, URI. It's good. Upvote. I don't think you do, right? You just have all the hashes like in there. Because what data from the questions does... I guess if you make an edit, right? Well, no, if you make an edit, you just say, hey, here's the new hash, and it gets accepted or not. Does the smart contract need any information from the hash, or is like the backend just like totally separate, and only on the UI you actually render that stuff? We can come back to that. Data stored in IPFS. I think that we don't even need the Chainlink part for now. We can add that later when we do more interesting stuff. Okay, let's try it. Got a whole bunch of crap in here. A whole bunch of stuff I don't really need. Let's clean this out. Keep that in there for now. ERC 77. Could this also be implemented using a decentralized database using Chainlink? Content lives off-chain and provided through several Chainlink nodes. Yeah, but now I'm thinking like, do I even need the data in the smart contract itself? That would be interesting. A decentralized database, a decentralized Chainlink database. I don't really know how that would work. Right now, I'm thinking of using like IPFS, which is like a pseudo decentralized database. But yeah, I'm thinking like, do I need to have any of the data really on chain? And I don't think I do. Because the contents of the question doesn't affect the logic at all, right? And just when you render your thing on the front end, you know what I'm saying? It's a good question though. You see 777. These have a 677. With the transfer and call. Who made that transfer and call? Oh, snap. Steve Ellis made this. Oh, hell yeah, Steve. What's the conversation like on this? Ethereum deleted a comment 2 days ago. What's the ERC 777? Why didn't 777 catch on? Yeah. Why? Uh-huh. Interesting. Okay, that's too bad. So I think we need a couple things here. We need okay, base.sol. Just do ERC20. Can host anything. An initial supply, I think, is a dumb idea. Let's just do for this, we'll give it an initial supply, but I think having a single initial supply is like not smart. We can just mint more later, actually. Yeah, mint messages. We'll mess with this. Yeah, I can host pretty much everything. I'll if I get to it, I'll show you an example. So this is the token that we're going to use. K-base token. I kind of want to like tightly couple the token with the smart contract. Or do I? Maybe I don't. So what does this look like? User asks a question. They get token. So this is going to need to own all the tokens. Just stake in all your questions. See, I don't want to make it hard though. I want to make it easier for people to be helpful. I feel like staking makes it hard for people to be helpful. Probably fine, right? Again, let's just get an MVP. Let's just get a V1 up. Let's have them stake, right? Let's have them stake. So this is going to be, we're going to have a script that's going to send this all the tokens. We're going to have what are we going to have? this. Function. I guess the front end would be decentralized. That's kind of wild. You could use Chainlink. Oh wait, no. You could use Chainlink nodes to render the front end, right? Because you would need Oh, that's interesting. Oh, that's very interesting. Okay, now I see what you're saying for like a decentralized database. So you'd use IPFS, but then to render it, you could use like a decentralized database. Well, no, because if your client is making the calls to IPFS, then you obviously want to be honest. Interesting. Function ask question, and this is just going to be like an IPFS token URI. Right? Acquire. No, to ask a question. What do we say in our little spitball? They get K-base token, so they're just gonna ask a question. They're gonna get it. We're not gonna require shit for this V1. Ask a question. They get K-base token. Okay, so then we'll send them some token. Thanks for asking the question. Oh, but if it's a shit question, we don't want to send them anything. If they get like an upvote, we'll send them a token. So ask question. And then what, do we just have a list of questions? Yikes. Then we'd use the graph. Do we want a map of questions? I think we just have a list of questions, right? Actually, we don't even need the whole URI. We just need the hash. CID. So we just need a string. Content addressing. Hex and not a string. Do I need this to be a struct? Public questions. Oops. Push. We probably also need the question asker. This needs to be a mapping now. No, that doesn't make sense. Probably do need a struct of the, yeah, okay, we need a struct. Question. Address. Asker. String CID. Push. I think this works, right? You already know we're doing this shit with Python. Probably should have comp test here, right? Let's see what finance does. So they have this comp test thing. I think this is what I want to do. This is where I would deploy one. Right, I think. Oh, they deploy it in. They deploy their stuff and not in the comp test. Gov. Oh, their governance. Right, because they're doing upgradable smart contract stuff. Fuck. Okay. So I probably need a proxy for all this shit. Let's worry about that later. Leave this blank for now. Cert. Just like double checking, make sure I have all my methods right here. You just keep going down the line. Fuck it. Let's just keep going down the line. Okay, so we're in a new folder. Oh no. Test. New folder. IPFS. Test. IPFS. Data. New file. Oh, what do I do? Grab this, put it here, move. Rename. Okay. Copy CID. File. List of CIDs.json. Stupid. Fix that later, actually. Cert kbase dot to load project. Right, because I need to do this weird mapping thing. Three point zero. Okay. Do I have to add it? Okay. Package is already installed. What? And what's the issue, huh? I do it like this. I can't use the @ symbol. Oh, because I'm a freaking idiot. But I've done this with... I've done this with this. Oh, it's because I put the @ sign. @Chainlink equals alpha chain. Yeah, Chainlink. Oh, this is different. Oh, got it. Got it. This. dependencies and remappings. No, okay. Declaration. Did I just import? Does this need to be in the contract? Am I just being a big dummy head? No. Variable function, variable struct, or modifier declaration expected. Import at opens up on. Looks right to me. It's the wrong Silk version. Compiler, Silk version 0.6 or import. Am I spelling import wrong or some shit? That's right. Does this work? K-base. Oh, it's K-base is having the issue. Oh, it's bitching about the import. Well, this should be outside. So that's probably why. Ah, okay. Am I just a big dummy head? I'm just a big dummy head. That's what it comes down to. Okay. Undeclared identifier, mint. K-base. Okay, here we go. Okay. Okay. Did you mean question? Yep. K-base token. Aha. Yep. Aha. Okay. Now we're getting somewhere. Oh, right. I need the... Oh, I think I need to give K-base initial supply or something. Yeah, I do. Okay. Okay, here we go. Contra call object is not subscriptable. Okay. Is it? Contra call object is not subscriptable. Oh, I gotta go like this. Just picked a 1 but got 0. K-base questions dot questions. Questions. Oh, I can't. Right. I can't get the whole thing. Ah, that's right. Okay. So my test then. Oh, okay. 0. Probably can't do that. 0, 0. There it is. Actually, can I do 0? Aha. Okay. That's much better. Oh. And there we go. Good. Status. Okay, cool. Okay, that pushes it on. Ask her CID. Does it need an answerer? Or I could just do RFK-based questions. I could do struct answers, address, answer, string CID. Right, so this is basically saying the schema is on chain. Do I want to separate? Do I want to have the answers be separate? Or should I just put them all in the same struct? It's kind of fun. Starting a project from scratch. Excuse me. Okay. Let's just, it's a V1. Let's just get something off the ground. Function. Question. String memory. Answers dot push. So this is when we'll require them to stake. So they'll need to stake here. Require we'll require them, they need to send some of this stuff. Oh, I don't have to require anything actually. We'll just do K-base token. I think I have to do approve, right? You know, I'll put the approve button on the front end. K-base token dot. Gotta update the. Well, if they're all using the same amount, I don't need to. If they're all using the same amount and they answer the question, they're clearly staking. Right. Oh, we will need a mapping actually instead of just a list. Maybe the mapping should be the IPFS hash. Oh, this is tougher. So I want to accept an answer to a question. Maybe each question has an answer list. That makes more sense. Yeah, that makes a lot more sense. Question, sticker, answer list. Answer, string ID, bool, accepted. Yeah, I think that makes more sense. Answer question, so it's going to be it probably can't be a question array. It's probably going to be a mapping. It's going to be a mapping of uint 256 to question. Public questions. request. And this is going to be like IDs. So it'll have an ID. I'm not going to store it in there for now. So ask questions. It's not going to be questions that got push. It's going to be questions. Actually, yeah, and 256. Question ID. Iterate or no. Even 256 public. Question ID counter. What happens if we delete a question that frees up the question ID? You can figure that out and reject a question. Oh, wait, no, we still want to, yeah, okay. Answer question. So we're going to do, so we need the IPFS CID answer question. Then we also need the question ID. So we're going to say questions, question ID dot answers. Push message.sender accept answer. Ah, fuck. All the answers are going to have to fucking ID. Or do they? Everything goes through the question. Read that. You went 256. Question ID. Answer ID. Accept answer. Got 10 more minutes. Question ID, answer ID. So we'll do questions, question ID. And then we'll give them the answer, stick them out. We just double it. All right, PyTest should break now. Oh, wait, I'm an idiot. Not being new. Questions, storage. Do we even have to pass that actually? Or can I leave it blank? We were push not found or not visible after arguing. Look up on instruct K-base knowledge. K-base questions to answer. Push. Questions store. Question ID. answers. Oh, we need the answer ID. Wait, no, questions, question ID, dot answers. But it's saying push isn't found. Struct answer memory. Does it need to be memory? Oh, this is a different one. Oh, whoops. Oh, that's why. Oops. Oh. Unimplemented copying of type struct. Okay, let's just do this. want them to be stored or memory anyways. Memory is not placeably convertible to type struct. Hey, you guys know why I'm getting this weird error? If I can't have a list in a struct. All right, well, I gotta jump off now. But this is an interesting question. I'll find out. Thanks, guys, for joining me. See you guys later. Peace.